Secure your Elixir apps with Paraxial IO. From code analysis and bot defense to dependency checks, they've got you covered. Elixir first design with GitHub integration. Elevate your security at Paraxial.io. What's up, guys? All right, so you probably noticed a little different thing. We have Paraxial sponsoring some of our videos every month now, so that's really exciting. And today is going to be a fun video. We are jumping into the Anti-Patterns Elixir guide. And our last one was just, the introduction. So it was really quick and short. Today we're doing the code-related anti-patterns. So I think we're going to learn quite a bit. A lot of good stuff. And it looks like chat might not be working. So that's kind of a bummer, but that's okay. Let's go ahead and jump right in. I'm going to just open up my browser here. And let me share my screen. And we're going to go to elixirlang.org. And I'll make this a little bigger for us. And then we're going to go up here to the guides. And on the left side, scroll down, find the anti-patterns section. And we're doing the code-related anti-patterns today. And then let me just make this piece bigger. All right. So code-related anti-patterns. This document outlines potential anti-patterns related to your code and particular Elixir idioms and features. The first one, comments overuse. Problem: when you overuse comments or comment self-explanatory code, it can have the effect of making code less readable. And here's an example. So we have a comment that says returns the Unix timestamp of 5 minutes from the current time. And then we have a private function here called Unix 5 minutes from now. And then another comment, get the current time. And then we call date time and call our UTC now, and that gets our current time. And then we have another comment here, convert it to the Unix timestamp, and we convert it to the Unix timestamp. And then we have another comment saying add 5 minutes in seconds, and then we have Unix plus 60 times 5. So this is a lot of comments, and I think what we're going to be seeing, I'm probably not going to be coding a lot, by the way, because I think this is more, we're going to read, absorb, and we can discuss what we're going through. There might be a couple spots in here where it makes sense to maybe open the IX shell. But for the most part, I think this is just going to be conversation based. And this is a pretty long guide. It'll help us get through quicker. Hey, what's up, Polar Bear? Happy you're here. Good to see you, man. So now the refactor, so refactoring that, all these comments. Prefer clear and self-explanatory function names, module names, and variable names when possible. If the example above, in the example above, the function name explains well what the function does, so you likely won't need to comment before it. The code also explains the operations well through variable names and clear function calls. So we could refactor it like this. All right, so we have a module attribute here. And that's good. So this is called 5 minutes in seconds. And what we're doing is 60 times 5. But at least we give an attribute name now instead of, so whenever you just see random numbers in code, it's always called magic numbers, right? You want to avoid that because anyone reading your code or, working in your code base after you or at the same time as you don't want to have magic numbers. You want to make sure they understand what it is. So obviously 60 times 5, when you read the attribute name here, 5 minutes in seconds, it makes a lot more sense than just having 60 times 5 in your code base. So we already had a very clear function name, so that makes sense. We don't need that comment, right? And we also already know we're getting UTC now just from the function name. And then we know just that we're converting that to Unix. So just our variable name here and the function we're calling is enough. And then you see that Unix now plus 5 minutes in seconds. So that's a lot nicer. We're calling that attribute the module attribute from up here, and it just gives it a good variable name now. So now I can probably read this and it'll explain everything that I just did. So we removed unnecessary comments. We also added the at 5 minutes and second module attribute, which serves the additional purpose of giving the name to the magic number, 60 times 5, making the code clearer and more expressive. Additional remarks: Elixir makes a clear distinction between documentation and code comments. The language has built-in first-class support for documentation through the @doc and @module doc and more. And you can see that in the writing documentation guide, which we already went through in our last, the Elixir getting started. So check out that video if you missed it. And yeah, so I think that makes a lot of sense. I think, especially when you're a new developer, you find the need of doing this because you think it's good documentation, but it can make things less readable, or it kind of spreads out and makes the function a little grosser. Like something more concise that you can just look at really quickly and see is pretty nice. All right, so complex else clauses in with. Okay, this will be a good one. Problem: this anti-pattern refers to with statements that flatten all its error clauses into a single complex else block. This situation is harmful to the code readability and maintainability because it's difficult to know from which clause the error value came. I'm glad this is in here, and I wish I would have read this a couple years ago because I had so many issues handling my errors correctly because I would always stack all my function calls in like my controllers with, and then you get very, what's the word I'm looking for? You get very like vague error handling, right? Because you end up having to write your own errors, or you do some weird pattern matching like this. So this is a good one. All right, so we have a function here called open decoded file. We're passing a path into that file. That makes sense. And then we're using with a with statement. So what's happening here is, okay, it's going to do this file or this function, and then it's going to do this function next. So what's nice with withs is you can pass in, we can take encoded and pass it into here. But the problem with this is if we get an error back at any time in this, it just goes to this else statement. And so like in this case, they're trying to cover the bad file and bad decoding errors with pattern matching, but you can't, it's a lot harder to control what error you're getting here, right? So in this case, they're getting just an error returned from decode 64, and they get an error tuple here, but it's kind of guesswork. And let's see. So then what they're doing is once they decode this, they're returning this string decoded, right? But the problem is this else statement and not handling errors very well. So in the code above, it's unclear how each pattern on the left side of our arrow relates to this error, assigns arrow relates to their error at the end. The more patterns in a with, the less clear the code gets, and the more likely it is unrelated failures will overlap each other. Yeah, so that makes a lot of sense. Refactoring. In this situation, instead of concentrating all error handling within a single complex else block, it's better to normalize the return types in specific private functions. In this way, with can focus on the success case, and the errors are normalized closer to where they happen, leading to better organized and maintainable code. All right, so let's see here. Yeah, this is good. So what's happening here is we refactored. We're still doing our open decoded file, and we're using our with statement, and we're calling our file read. But our file read now is a private function that calls our file.read and passes in the path. And then in our own case statement, we're handling just the file.read, returning the contents and the error itself. And then the same thing with the decode. So we're either returning an OK tuple with the decoded value or the error value. And then we can pass our expected tuple back. So that is a lot nicer. And then so what's good with this is by default, the with statements will just raise the error in the else block if any of these fail, because that's what's coming back. So that is a lot nicer. And just breaking things up in separate functions makes it a lot easier to handle your errors. Because imagine if you have a third or fourth function in this with statement, at least you can handle all your errors. And then you return your error tuple back in the same format with just a different message. So it would be a lot easier to debug as your code base grows. All right, complex extractions in clauses. Problem: when we use multiple clause functions, it is possible to extract values in the clauses for further usage and for pattern matching / guard checking. This extraction itself does not represent an anti-pattern, but when you have extractions made across several clauses and several arguments of the same function, it becomes hard to know which extracted parts are used for the pattern / guards and what is used only inside the function body. This anti-pattern is related to unrelated multi-clause function, but with implications of its own. It impairs the code readability in a different way. I don't know, Dweezy. I'm not very familiar with Golang, unfortunately, where anything you call either gives you the return value or an error. Well, so not always, but I know with statements, if an error is returned, that it'll return it to you, if that's what you're asking. All right, so back to our unrelated multi-clause function. All right, so our example here, the multi-clause function drive arity1 is extracting fields of a user struct for usage in the clause expression. All right, so age, and for usage in the function body, name. All right, so we have a drive function here, and we are pattern matching. Oh, no, so we're passing in a user, and then we're using a guard to check the age. So if it's above or equal to 18, the person can drive. If the age is less than 18, the name cannot drive. So the thing they're telling us to avoid here is, look, we're passing in a full struct, and what's unclear here is they want us to, up here in the parameters, is to only pull out age if we're using only age for the guard. And then we can also pull out name within the body function down below, instead of making it all available in our struct being passed into the function, which makes sense. So while the example above is small and does not constitute an anti-pattern, it is an example of mixed extraction and pattern matching. A situation where drive was more complex, having more clauses, arguments, and extractions would make it hard to know at a glance which variables are used for pattern and guards and which ones are not. So that makes sense. So so we're going to refactor this to a solution. This anti-pattern is to extract only the pattern / guard related variables in the signature once you have many arguments or multiple. Okay, yeah. So now up above here, we're passing in a user. And since we're only using age in our guard, we're pattern matching age right here. Okay, so, and then inside of our function body, we're then pattern matching name out of user for our return string. I think like this is a really simple example, but like if you had, more pattern matchings and more guards off the same function, this would make a lot more sense, because like you might use more things from a user inside of the functions, but if all we're using at the guard and pattern level level is age, it makes it really clear very quickly. So that makes sense. I think writing functions this way is definitely very easy to do. I probably have done it, and I probably have code today that does this. So this is good to know. I like the level of extraction. There is a little bit of clarity added. So that's good to know. All right, dynamic atom creation. Ooh, yeah, we always talk about don't create dynamic atoms. I like that this is in here. All right, problem. An atom in an Elixir basic, an atom is an Elixir basic type whose value is its own name. Atoms are often useful to identify resources or express the state or result of an operation. Creating atoms dynamically is not an anti-pattern by itself. However, atoms are not garbage collected by the Erlang virtual machine, so values of this type live in memory during a software's entire execution lifetime. This is good to know, right? The Erlang VM limits the number of atoms that can exist in an application. By default to it's 1,048,576. which is more than enough to cover all atoms defined in a program, but attempts to serve as an early limit for applications which are leaking atoms through dynamic creation. So like, yes, this is a very big number, but this is why you don't want to just take like a dynamic string, right? And say, what is the function? String.toAtom. You don't want to just do that off dynamic values coming in, because if a client or a user of your application knows that that is a vulnerability in your code, they could crash your system by creating, over 1 million atoms dynamically, which is not good. So for these reasons, creating atoms dynamically can be considered an anti-pattern when the developer has no control over how many atoms will be created during the software execution. This unpredictable scenario can expose the software to unexpected behavior caused by excessive memory usage or even by reaching the maximum number of atoms possible. All right, example. Picture yourself implementing code that converts string values into atoms. These strings could have been received from an external system, either as part of a request into our application or as part of a response to your application. This dynamic and unpredictable scenario poses a security risk, and these uncontrolled conversions can potentially trigger out-of-memory errors. They said that better than how I explained it. All right, so we have a module here called myRequestHandler, and we have a function called parse. All right, it is taking a map with a key status and a key message, and that is a payload being sent into this function. And since we're pattern matching, we don't need access to payload, but we're pattern matching to status and message. Okay, that makes sense. But then it looks like inside of our function, we're taking the status and doing string.toAtom and then returning the message. So here in our IEX shell, we are calling .parse and we're passing in an OK status string, and then we're converting it to an atom. So this would be dynamic, right? Because we're calling this outside of our application. And this could be bad, right? For lots of reasons. Someone could just hammer out, a script that creates 1 million of these atoms, right? And obviously, like once OK exists, it's there. But if they're doing other statuses that aren't covered, you're just creating all these dynamic atoms. So when we use string.toAtom arity1 function to dynamically create an atom, it essentially gains potential access to create arbitrary atoms in our system, causing us to lose control over adhering to the limits established by the beam. This issue could be exploited by someone to create enough atoms to shut down a system. Yeah. All right. So refactoring. To eliminate this anti-pattern, developers must either perform explicit conversions by mapping strings to atoms, or replace the use of string.toAtom with string.toExisting atom. And explicit conversion could be done as follows. So I like a lot of times when I am calling like modules dynamically, they're always converted into atoms, right? But I will always use to existing atom. So like if a module you're trying to call dynamically doesn't exist, an error will just get handled and it's good to go. You won't accidentally be creating atoms everywhere. So whenever you're dynamically doing things with atoms that already exist on your system, always use to existing atom. All right, so here we are mapping strings. Okay, so this is a refactoring our parse, and we created a function called convert status. And all we're doing is pattern matching to a string and then returning an atom that we're creating. So this creates 3 atoms that we know exist, right? So we're just handling it. And so obviously, if we pass in a status below, like status not seen anywhere, we'll get a function clause error, no function clause matching that request. So that's good, right? So you're handling the only statuses you want to handle in your application, which is good. All right, so by explicitly listing all supported statuses, you guarantee only a limited number of conversions may happen. Passing an invalid status will lead to a function clause error. All right, an alternative is to use a string to existing atom, which will only convert a string to an atom if the atom already exists in the system. So we can just, instead of writing all those pattern matching functions, we can just do string.toExisting atom and pass in our status. Now, when we pass in a status that's not expected, we get an argument error, and so it is not, we'll get a not already existing atom. Now, you're going to obviously have to have atoms existing, right? We're going to have to make sure our OK, our error, and our redirect atoms do exist. So I think they're going to be touching on that. Yeah, okay. So in such cases, passing an unknown status will raise as long as the status was not defined anywhere as an atom in the system. However, assuming status can either be OK, error, or redirect, how can you guarantee those atoms exist? You must ensure those atoms exist somewhere in the same module where string.toExisting atom is called. For example, if you had this code, all right, so we have another function called handle status, and we just have a case, and we're returning case for OK, error, and redirect. All the valid statuses are defined as atoms within the same module, and that's enough. So just having another function with these atoms is enough that they exist. So that's actually good to know. If you want to be explicit, you could also have a function that lists them. So we could just have a function that is valid statuses, and we can return them all in a list. However, keep in mind using a module attribute or defining the atoms in the module body outside of a function are not sufficient, as the module body is only executed during compilation and is not necessarily part of the compiled module loaded at runtime. Okay, so that's good to know. So if we just had, valid statuses as a module attribute, there's a good chance that they will not be there, but including them inside of a function, you'll have them. That's good to know. I don't think I knew that. I mean, I think you would figure it out really quick when you get your error back, but it's good to know. It's good to know why. All right, long parameter list. Problem. In a functional language like Elixir, functions tend to explicitly receive all inputs and return all relevant outputs instead of relying on mutations or side effects. As functions grow in complexity, the amount of arguments or parameters they need to work that may grow. So to a point where the function's interface becomes confusing and prone to errors during use. So an example here is in the following example, lone arity6 function, it takes too many arguments, causing its interface to be confusing. potentially leading developers to introduce errors during calls to this function. So yeah, like obviously this function taking 6 parameters is already crazy. You don't want to do that. So it's taking a username, an email, password, user alias, book title, and book ed. I don't know what that means. Maybe we'll figure that out. But anyways, so refactoring this to address this anti-pattern related to arguments. Related arguments can be grouped using key value data structures such as maps, structs, and even keyword lists in the case of optional arguments. So this effectively reduces the number of arguments, and the key value data structures adds clarity to the caller. So that makes sense. So for this particular example, the arguments to loan arity 6 could be grouped into 2 different maps, thereby reducing it to arity 2, which is way better. All right, so what they did here is we took that loan function and we created a map. Okay, so we're taking this in, we're passing in a user map, and then we're just pattern matching to, name, email, password, and alias. That makes sense. And then we're passing in another map that we're calling book. Okay, and that is pattern matching the title and ed. Addition maybe. Well, that's what we'll call it, the book edition. So that makes a lot more sense. So now it just takes 2 things. You pass in your map and your 2 maps, and that's a lot clearer for someone reading your code and using your code. So in some cases, the function with too many arguments may be a private function, which gives us more flexibility over how to separate the function arguments. One possible suggestion for such scenarios is to split the arguments into 2 maps or tuples. One map keeps the data that may change, and the other keeps the data that won't change, read only. This gives us a mechanical option to refactor the code. Other times, a function may legitimately take half a dozen or more completely unrelated arguments. This may suggest the function is trying to do too much and would be better broken into multiple functions, each responsible for a smaller piece of the overall responsibility. That makes more sense, right? So if you have a lot of unrelated things going into a function and you have like 8 arguments that you need, your function's probably doing too much. And I think that's one of the great things about immutability and the functional paradigm is you're kind of forced to write good code because that is very apparent right there, right? Like you're passing in 8 arguments that aren't related, so you can't group them in a map for just like user and book. Your function's probably doing too many things. And I know it's a very difficult thing, especially when you're new to programming. Especially in object-oriented world. I remember I used to make functions that did everything. Why would you write 5 functions when you can write 1 function that does it all? And it kind of breaks down to one, you're making one very complicated function that's going to be hard to debug and to write tests for. Testing is a good way to make your functions stick to just doing one thing instead of multiple things as well. But I think the immutability aspect where you can kind of just pipe functions in a row, you start writing cleaner code that only does one thing. And I think that's a good thing. All right, namespace trespassing. Problem. This anti-pattern manifests when a package author or a library defines modules outside of its namespace. A library should use its name as a prefix for all of its modules. For example, a package named mylib should define all of its modules within the mylib namespace, such as mylib.user, mylib.submodule, mylib.application, and mylib itself. So if you write any Elixir code, you're probably already doing this, not even realizing why. This is important because the Erlang VM can only load one instance of a module at a time. So if there are multiple libraries that define the same module, then they are incompatible with each other due to this limitation. By always using the library name as a prefix, it avoids module name clashes due to the unique prefix. That makes sense. Example. This problem commonly manifests when writing an extension of another library. For example, imagine you are writing a package that adds authentication to plug called plug auth. You must avoid defining modules within the plug namespace. Okay, sorry, I gotta take a breath. Reading, man, it takes it out of you. All right, 1 second. Okay, so we have a def module here, plug.auth. Even if plug does not currently define plug.auth module, it may add such a module in the future, which would ultimately conflict with plug auth definitions. So refactoring, given the package is named plug auth, it must define modules inside the plug auth namespace. So just name the module plug auth, camel casing. All right. Yeah, that makes sense. All right. So additional remarks. There are a few known exceptions to this anti-pattern. Protocol implementations are, by design, defined under the protocol namespace. All right. In some scenarios, the namespace owner may allow exceptions to this rule. For example, in Elixir itself, you define custom mix tasks by placing them under the mix task namespace, such as mix.tasks.plugauth. Yeah, so if you've ever written a task, you know this, right? So you always place them in the mix task module. And if you are a maintainer for both plug and plug auth, then you may allow plug auth to define modules within the plug namespace, such as plug.auth. However, you are responsible for avoiding or managing any conflicts that may arise in the future. Ride the lighting under atoms and modules. What are you referring to right now? Is that one of my old videos? It's probably one of my old videos. Let me look. If I can find it. Let's see, content, my live streams. When did I do module attributes? I don't remember. We'll wait for you to clarify the docs from let me find that. I know what you're talking about. Okay, so atoms and modules. Oh, I see. Where is this one? Atoms and modules. Since Elixir is a compiled language, the atoms defined in a module only exist after said module is loaded, which typically happens whenever a function in the module is executed. Therefore, it is generally recommended to call string.toExistingAtom only to convert atoms defined within the module. Yeah, awesome. No, hey, thanks for pointing it out, because I should have just clicked on this too, because going through this stuff, I think we went through this. What section is this in? We definitely did not. So this is the string module. Okay. But yeah, it's good to know that stuff. And I forget half the things that I learn anyways. And then you're like, I think I learned this somewhere. And then it usually comes back pretty quick. Where did I just leave off? Plug.auth. Okay, non-assertive map access. It says only to use it in the module when you're using it in. I have broken that rule. Only to use it in the module. Oh, I see what you're, so if you're using two existing atom, yeah, you want to make sure that those atoms exist within the module that you're calling that function, which makes sense, right? And well, I feel like there might be, I should find this out before I say this, or actually people can just make fun of me if I'm wrong. It doesn't matter. But like, so like when you have a module created, that module name is an atom in the system. So I think it would be safe to use that in a module if you're accessing or reading a module by its atom name. I would think that'd be okay because you know it exists, but maybe I'm wrong there. I don't know. Someone yell at me or correct me or something, but maybe my example isn't a good. Maybe it's an anti-pattern, but I don't know. I use it all the time to reference modules that I know exist from another module. Maybe I'm wrong, but I feel like if you like, I want an error if that module doesn't exist, so it's good, right? I think it's probably fine. All right, so non-assertive map access. Oh yeah, this is going to be a good one. All right. Sorry if, hopefully you guys can't hear cars driving by because I have my door open right now. It's a really nice day. So hopefully my mic's cutting it out. Ideally, that's what's happening. All right, so non-assertive map access problem. In Elixir, it is possible to access values from maps, which are key value data structures, either statically or dynamically. When a key is expected to exist in a map, it must be accessed using the map.key notation, making it clear to developers and the compiler that the key must exist. If the key does not exist, an exception is raised, and in some cases, also compiler warnings. This is also known as static notation, as the key is known at the time of writing the code. Yeah, and I think we learned this in the Elixir Getting Started playlist, but it's good to know. So when a key is optional, the map .key notation must be used. So I don't know why I'm blanking. I can't remember what this is called, but we're basically our map name, and then inside of square brackets, you're looking for a specific key. And this allows a value. So if that key doesn't exist, you'll get nil returned, right? And so using this dynamic notation, we'll call it dynamic notation. That makes sense. It supports dynamic key access, such as map some variable, blah, blah, blah. And like I said, it returns nil if it doesn't exist. When you use map, I don't know why I'm struggling with, when you use the dynamic notation to access a key that always exists in the map, you are making the code less clear for developers and for the compiler, as they now need to work with the assumption that the key may not be there. Okay, this is a fantastic point, because I always actually used to question, I never understood, like, why would I use the dot notation versus the key notation? And this is really good. So if you know your map is always going to have that key, you should be using the dot notation instead of passing in the key notation. That's great, right? So this mismatch may also make it harder to track certain bugs. If the key is unexpectedly missing, you will have a nil value propagate through the system instead of raising on map access. All right, cool. Example, the function plotArity1 tries to draw a graphic to represent the position of a point in a Cartesian plane. This function receives a parameter of map type with the point attributes, which can be a point of a 2D or 3D Cartesian coordinate system. This function uses dynamic access to retrieve values for map keys. All right, so inside of our graphics module here, we have a function called plot. It takes a point, and our point is clearly a map, right? And we're accessing, or we're returning our points. So we're accessing them in the dynamic access with our keys. So point X, Y, and Z. Okay. And then in the example below, point 2D, we're assigning just X and Y. Okay. And then point 3D, we're assigning X, Y, and Z. And then when we call our function plot, we pass in 2D here and we get our third. So we get Z back as nil, which is expected. And then when we pass in the 3D point, we get all 3 points back, which is expected too. So given we want to plot both 2D and 3D points, the behavior above is expected. But what happens if we forget to pass in either X or Y? So a bad point would be just Y and Z. And then when we call the plot function, we get nil for X. And obviously in both circumstances, whether it's 2D or 3D, we need X and Y. So the behavior above is unexpected because our function should not work with points without an X key. This leads to subtle bugs, as we may now pass nil to another function instead of raising early on. This is a really good example. I like this. All right, so refactoring. To remove this anti-pattern, we must use the dynamic map key syntax and the static map.key notation according to our requirements. So we expect X and Y to always exist, but not Z. The next code illustrates the refactoring of plot arity1, removing this anti-pattern. All right, so we always expect X and Y to be there. So now we're using the dot notation, and it'll raise an error if this is missing. And then we're doing the dynamic for Z because we're allowing nil to be there for 2D plots, right? So now when we call point 2D, we get 2X and nil. And then when we pass our bad point in, we get our key error. So X was not found. And yeah, that's awesome. I love this example. That's really cool. Because I know if you're new to Elixir and maps, you're probably wondering, why are there so many different ways to call your values? And this is a good example of when and how you would use the dynamic and dot notation. I love it. So overall, the usage of map.key and the dynamic key encode important information about your data structure, allowing developers to be clear about their intent. So see both map and access module documentation for more information and examples. So I know we've already gone through map. I don't remember if we've got, so check out map again, and maybe check out the video. I know I live streamed that one. And then access behavior. I actually don't know if we did this one or not. I don't remember, but this is also a good one to go through. I feel like we might have. My memory is bad, but that's also a good one to check out. All right, an alternative to refactoring this anti-pattern is to use pattern matching, defining explicit clauses for 2D and 3D points. So you can have a plot for 3D where you have a map go in and you require X, Y, and Z. If you get all those, it's a 3D point. And then you can have 2D that will just be the fall through. So if Z doesn't exist, then X, Y, and Z, and you just return X, Y. I think that is good. I would probably lean towards writing code this way. I think this is like a lot more clear. I personally like pattern matching, but pattern matching is especially useful when matching over multiple keys as well as on the value themselves at once. Another option is to use structs. Oh, structs would be good too. By default, structs only support static access to its fields. In such scenarios, you may consider defining structs for both 2D and 3D points. Okay, so let's see. Okay, so we're creating a whole point. I mean, depending on the project, you might want to create structs, right? And then you can enforce your keys X and Y. Okay, I like this little use little module attribute. Generally speaking, structs are useful when sharing data structures across modules at the cost of adding a compile time dependency between these modules. If module A uses a struct defined in module B, A must be recompiled if the fields in struct B change. Additional remarks. This anti-pattern was formerly known as accessing non-existent map/struct fields. Okay. I think my favorite here would be this pattern matching, but I also like this reiteration of when dot notation is used. I like that a lot. All right, non-assertive pattern matching. Problem. Overall, Elixir systems are composed of many supervised processes. So the effects of an error are localized to a single process and don't propagate to the entire application. A supervisor detects the failing process, reports it, and possibly restarts it. This anti-pattern arises when developers write defensive code or imprecise code capable of returning incorrect values, which were not planned for, instead of programming in an assertive style through pattern matching and guards. All right. Oh yeah, this is a good one. The function getValueArity2 tries to extract a value from a specific key of a URL query string. As it is not implemented using pattern matching, getValueArity2 always returns a value, regardless of the format of the URL query string passed as a parameter in the call. Sometimes the returned value will be valid. However, if a URL query string is an unexpected format, it is used in the call, getValueArity2 will extract incorrect values from it. All right, so let's check this out. We have our extract module here with a function called getValue. It's taking a string, which is a URL with parameters, I believe, and the desired key that we're looking for. All right, so let's see. We are splitting our string. All right, is there an example of the string being? Okay, I guess down here. Okay, so we're splitting our string. All right, so we have a query string, right? And so we have our key and our value, and then the second, and then the ampersand is separating the next key and value. Okay, so we're splitting our string at the ampersand. Okay, and then we are finding, and then we are iterating through our values and splitting at the equal sign. Okay, and our key value is the left side, and then our enum key value, and then our key value. Okay, so we are finding, first, we're splitting our string. So that creates a list, right? A list of all separated values. So we have a list, one value is this, the next value is this, and the next value is this. And then we're iterating through. So enum, find value, we're passing in parts. So our parts is that list. And then each pair in that has an equal sign between the key and the value. So we're splitting that, okay? And then our key value list is here. And then so at index 0, that's our key. So as long as that equals our desired key, we know at index 1, that is the value we're looking for. Okay, that makes sense. So we're getting our value, we pass this in, okay, and we want our value for lab. So that's going to return this ASERG, okay? And then we're going to do that again for university, and that's UFMG, and that works there. All right, so now we have an unplanned URL query string format, unplanned value extraction. So let's see here. We have our university key, and then equals institution, but then we have an equals UFGM. So we have something that doesn't match our pattern, right? We have a key, a value, and then a value, I guess. So instead of an ampersand in between. So let's see, we're looking for university and we get institution back. Okay, so that makes sense because we split it at this. Why not institution? Why not institution equals? That's because, okay, so we get institution back because we split it. And so we have a list of 3 things. Okay, so it's just buggy code. It's not working as expected, which is why you would want to write tests for this as well, right? So refactoring, to remove this anti-pattern for our getValueArity2 function, it can be refactored through the use of pattern matching. So if an unexpected URL query string format is used, the function will crash instead of returning a invalid value. This behavior shown below allows clients to decide how to handle these errors and doesn't give a false impression that the code is working correctly when expected values are extracted. All right, so let's see what is happening here. We're still splitting this at the ampersand. And then we are pattern matching here. Okay, at the equal sign, and we're pattern matching to our list. So key and value. So is key our desired key, and then value. So let's see. This will still work, obviously, for name, because name is Lucas. And then when we pass in the unexpected value, university, which has institution and UFGM, no match on the right side because we have a list that is 3 values long. We have a list that is 3 indexes long. Okay, so that's really cool. This is a good way to solve it. And then let's see here. So yeah, and then we could also make this a case statement, right? And pattern match to key value, or we could pattern match to a match error and handle that accordingly. So that's really cool. Oh, here, and they even suggest that. So Elixir and pattern matching promote an assertive style of programming where you handle the known cases. Once the unexpected scenario arises, you can decide to address it accordingly based on practical examples or conclude that the scenario is indeed invalid and the exception is the desired choice. I think the exception would probably be great, right? Because you want people to know, hey, your query string is not what is expected by our code here. So you can use case arity 2 is another important. So yeah, like I was saying, we could call that function, right? And then if it returns our value, great. If it returns an error, we can handle it differently. In particular, avoid matching solely on the underscore as shown below. So they're saying don't just have a fall through that would call anything. Explicitly handle the error atom, because the underscore is less clear in intent and it may hide bugs if some function arity 1 adds a new return value in the future. Because yeah, if some function adds something new, you wouldn't know you're not handling the cases right in every place that you're calling that function. So if you explicitly handle all your expected return values, you're kind of forced to go back and handle whatever another tuple might be, whether it's OK, error, or redirect like we were looking at earlier. This anti-pattern was formerly known as speculative assumptions. Okay. That's a good section. All right, non-assertive truthiness. Problem. Elixir provides the concept of truthiness. Nil and false are considered falsy, and all other values are truthy. Many constructs in the language, such as ampersand, arity 2, the cons operator, cons, and then the not arity 1, handle truthy and falsy values. Using those operators is not an anti-pattern. However, using those operators when all operands are expected to be Booleans may be an anti-pattern. All right, so I feel like the and or and not, like this syntax you're used to using in other languages, right? And so an example, so the simplest scenario where this anti-pattern manifests in conditionals such as, so if is binary name and is integer age, do this, else do this. So if it's not a binary and if age is not an integer, you wouldn't enter the if block, right? So given both operands and are Booleans, the code is more generic than necessary and potentially unclear. Okay. To remove this anti-pattern, we can replace the and operators in the or and with the and arity 2 or arity 2 and not arity 1 respectively. These operators assert at least their first argument is a Boolean. Okay. I mean, I guess. So I think just like in Elixir itself, you want to use the and, or, and not. Oops, I clicked on one. And so instead of using the double ampersand here, write out and, because I do think it is a lot clearer. So this technique may be particularly important when working with Erlang code. Erlang does not have the concept of truthiness. It never returns nil. Instead, its functions may return an error atom or an undefined atom. In places an Elixir developer would return nil. Therefore, to avoid accidentally interpreting an undefined atom or an error atom as a truthy value, you may prefer to use the and, or, and not exclusively when interfacing with Erlang APIs. I think that's really good to know. That's good. That's awesome. I guess I never really knew that. And I think I'm going to start learning more Erlang too and make some content about that, because I don't remember who I was talking to. I think Adolfo, in one of my recent podcasts, we were talking about Erlang not getting enough love, and I think it would be cool to make some content. But all right, that was a long one, guys. Woo! An hour of reading. My throat is dry. But I thought that was really awesome. Code-related anti-patterns. On Thursday, we are going to be doing the next anti-pattern, which is design-related anti-patterns. And I think that one will be a lot of fun as well. And yeah, thanks a lot for tuning in. And that was code-related anti-patterns. I'll see you guys on Thursday. Have a good one.